Hello, this is Mrs. Scarpel, and I am going to go over some key phrases that you need to know when writing inequalities to solve a problem in context, but I'm also going to go through the process of solving inequalities once they are written and writing the solutions in both interval notation and set notation. So when you have these phrases like we have here on the screen, you really need to think about the meaning behind the phrases. So no more than. I can't have a number that is more than the number. I'm thinking this should say a no more than 7 on here since everything else is in sevens. So no more than 7 means it can't be 8, can't be 7.2, but it could be less than 7. And if you think about it, the number 7 itself isn't more than 7. So when you look at these expressions, you want one that's going to show that the value could be less than 7, but also equal to 7. So our inequality for this phrase would be x less than or equal to 7. A minimum of 7 means it can't go any lower than 7. So it has to be more than 7, but it can be equal to 7. In that case, you want to use greater than or equal to 7. More than 7 is going to be the reverse of no more than 7. So we want a number that's larger than 7. And because it has to be more than 7, we actually do not want to include the 7. So we really are strictly saying that we want x to be greater than 7. No less than 7 is another way of saying a minimum of 7. We don't want to go any lower than 7. We can be exactly 7 though. So it's going to be just like the minimum, x greater than or equal to 7. At least 7 means it can't be any less than 7, but it could be equal to again. So x has to be greater than or equal to 7, just like minimum, just like no less than. Well, if minimum, it can't be any lower. Maximum, it can't be any higher. So it has to be less than, but it could be equal to 7. So we want it to be just like the no more than 7. We want it to be x is less than or equal to 7. Cannot exceed 7 means it can't be any higher than 7. Can be lower than 7, but not higher. And it can equal 7. So this is going to be x is less than or equal to 7 as well. Fewer than 7 means we don't want to have 7 at all, but we also don't want to go any higher. So fewer than 7 is going to be x less than 7. Because we don't want it to include, we don't underline the inequality. So you're going to want to keep these phrases in mind as you're setting up the following problems. So we have Elvira's cafeteria, just like we've been using in class. Has those cute little cartons of milk that are typical of school lunch. The milk supplier charges 35 cents per carton of milk in addition to a delivery charge of $75. I'm going to pause there and I'm going to write the expression that fits that sentence. So 35 cents per carton, that's going to be 0.35x plus the $75 delivery charge. What is the maximum number of milk cartons that Elvira can buy? So maximum number. Maximum, it can't be any higher, can be lower, can be equal to, so we want to say less than or equal to, that Elvira can buy if she has budgeted $500 for milk. So that $500 is the maximum she can spend on milk. Now when you're solving an inequality, for the most part, it's the same as solving an equation. You want to undo it in the same way that you would an equation that has an equal sign. So the last thing that I would do to this x value after I multiply by 0.35 is add the 75. So that's the first thing I want to undo. So now we have 0.35 x is less than or equal to 425. Now I want to undo the multiplication that is happening with the 35 cents per carton and divide by 0.35 on each side, which gives me a solution of x less than or equal to, let me grab my calculator here quick, and I will take 425 and divide it by 0.35, and we have 1,214.3. Now, if you think about it, she is purchasing cartons of milk. She's not going to be able to purchase a partial carton. We can't go any higher than 1,214, so I wouldn't round this up to the next full carton. So I'm going to round it down to the last carton. So our solution is going to be a maximum of 1,214 cartons of milk. Now, we're being asked to write our solution in both interval and set notation. Interval notation is the values that we could actually use. So it's possible that she doesn't need to order any milk, so we can include 0. But considering it's cartons of milk, we can't use any negative values. So the interval is going to start at 0, and the maximum is going to be 1,214. I put square brackets on each end because she could purchase no milk, or she could purchase 1,214 cartons, or somewhere in between. Set notation. This is where we use the fancy bracket, and we're going to say x such that. The vertical bar means such that. And then we're going to write the inequality that works for this. So x is less than or equal to 1,000. Actually, I can't just say less than, because I would end up including the negative value. So I want to make this start just like my interval. I want x to be between 0 and 1,214. And then use the fancy brackets. So the reason I have a less than on each side of the x is because this is reading as 0 is less than or equal to the number of cartons of milk, which is x, which is less than or equal to the 1,214, which we said was the maximum she could purchase. Number 2, Elvira has to keep ranch dressing in stock. And each day, the students go through about 2.25 gallons each day. She started the year with 130 gallons. She needs to have at least 20 gallons when she reorders to have enough. So we need to find how many days will her ranch dressing supply last before she needs to reorder. Well, I'm going to take the amount she started with, which is the 130, and I'm going to subtract the amount that gets used each day. So 2.25 x. X is the number of days. At least 20, so it can't be lower than 20. So we need more than 20, but could be equal to 20 before she has to reorder. So we're going to find within how many days can she reorder. Again, we're going to solve. The dividing by the 2.25 will be the last thing we do because it's the first thing that's being done to x. When you're undoing this 130, do not pay attention to the sign behind it. Keep in mind this 130 is a positive value. So if we want that to become 0, we need to subtract 130 from each side. So we have negative 2.25x is greater than or equal to negative 110. Divide both sides by the negative 2.25, and this is when you need to remember something. When you multiply or divide by a negative value, that inequality has to reverse. So we have x is now less than or equal to, if I take negative 110 and divide it by negative 2.25, I get 48.9. So she has to order between 0 and 48 days. So the maximum number of days before she needs to reorder And again, I'm not going to round this up because it can't be more than 48.9. So we're going to go and round it down to 48. The maximum number of days before she reorders is 48. I'm going to do my interval and set notation very similar to what we had before. Because the maximum is 48 and we can't have negative time, my interval is going to start at 0. And we said the maximum is 48. Set notation, fancy bracket, x, vertical bar, 0 is less than or equal to x is less than or equal to 48. So we use the same numbers in our notations. Next example. We have prices on food change throughout the year. She's ordered veggie burgers 4 times and paid $78, $72, $87, and $90. To stay within her budget, she needs to be sure that the average order is not more than $82. How much can she spend on the 5th order to keep the average order within her budget? So you need to remember that to find an average, you add up the numbers and divide by the number of numbers. So we're going to add 78 to 72 to 87 to 90, but I'm going to add a plus x for that 5th order. We're looking for what can that value be. That sum will get divided by 5, and it cannot be more than $82. So it can be less than or it could be equal to $82. I'm going to start by simplifying my numerator there. So 78 plus 72 plus 87 plus 90 is 327. Plus x divided by 5 is less than or equal to 82. Now I need to undo the divide by 5, so I multiply both sides by 5. And we have 300, that should be 327, not 325. Let me fix that. 327 plus x is equal to 82 times 5 is 410. Subtract the 327, and we have x, and that shouldn't be equals either, should still be less than or equal to. X has to be less than or equal to 83. So the fifth order cannot be more than $82. So interval notation, again, you can't have a negative cost, so our interval will start at 0, and it will go up to, did I say 82? Our work says 83. So our interval will go from 0 to 83. Our set notation, fancy bracket x, vertical bar, 0 is less than or equal to x is less than or equal to 83. Next example. Elvira can order ready-made pizzas for $4.50 each. She can make them by spending $44.20 on ingredients and $6.25 per pizza on labor. So for how many pizzas is it cheaper for the cafeteria to make pizzas themselves rather than make them ready-made? So the ready-made was $14.50 each. So that's going to be 14.50x. We want the cafeteria to be cheaper, so we want it to be less than that, or we want the ready-made to be more than the cafeteria. The cafeteria spends $44.20 on the ingredients plus $6.25 per pizza on the labor costs to make them. To solve this, I would like to get x on the same side. So I'm going to undo the plus 625x by subtracting 625. And that's 825x is greater than 44.20. Divide both sides by 8.25. And this time we're dividing by a positive, so we do not need to reverse the inequality. And we end up with x has to be more than 44.20 divided by 8.25 has to be more than 5.4. Well, we don't purchase partial pizzas. We don't make partial pizzas. We make a pizza or we don't. So when is it cheaper? It's cheaper when the cafeteria makes more than 6 pizzas. This is a case where we want to round up to the nearest whole number from 5.4. Cafeteria makes 6 or more pizzas. So the interval notation, because it's going to be more or equal to, I'm going to start my interval at 6, but I don't know when they're going to stop. So we can say up to infinity. So for the set notation, I'm not going to write the sandwich type compound that I've been writing. It's going to be the fancy bracket X, vertical bar, and I'm going to say X is greater than or equal to 6, because that's the notation that works for this situation. Next example, we're comparing lettuce from two different suppliers. So we have Val's Veggies, charges $250 for delivery and $1.50 per bag. Sally's Salads charge $100 for delivery plus $4 per bag. How many bags of lettuce must be purchased for Val's Veggies to be the cheaper option? So Val's Veggies was $250 plus $1.50 for each bag. We want that to be cheaper, so we want it to be less than the $100 plus $4 per bag. So 100 plus 4x. I have x on both sides. First thing I want to do is get x on one side. I'm going to subtract the 1.50x on each side, and I will have 250 is less than 100. 4 minus the $1.50 is $2.50, so plus 250x. Now I will subtract the 100 to isolate the 250x. So we have 150 is less than 250x. Divide both sides by 250. And we end up with x, no, not x. We end up with a number is less than x. So 150 divided by 2.50, we have 60 is less than x. So this is actually when x is more than 60. So when more than 60 bags, let's start writing this over. When more than 60 bags are ordered, Val's Veggies is cheaper. So the interval notation for this will start at 60, but we're not including 60 because it has to be more. So I'm going to use a soft parenthesis, 60, and then however many more she needs. That could go on to infinity. So we use a soft parenthesis on that. Set notation, we're going to have x, vertical bar, x greater than 60 is the set notation. And I believe I have one more example here. Each student who buys a school lunch pays $2.75. Typically, the cafeteria brings in between $1,168.75 and $1,438.25 each day. So how many students does the cafeteria usually serve? Well, somewhere between 1,168.75 is going to be less than the $2.75 per student. Which is going to be less than the $1,438.25. So because this says between, it doesn't say that it's including those values. I am not going to include them by using an equal to symbol. So I need to solve for x. X is being multiplied with 2.75. So I'm going to divide the middle by 2.75, but I'm also going to do this on each end, each inequality. So it's like solving two inequalities at the same time when it's written as an and compound inequality in this form. So 1,168.75 divided by 2.75 is 467.5. And then we have 1,438.25 divided by 2.75 is 523. I'm just double checking to make sure I did the first one correctly. Yes, I did. Now we're talking students here, and you can't have half of a student. So Elvira serves between $467 and 523 students each day. So let's write our notations. Interval notation, it's between those values. So 467, 523. We're not including the values, that's why they're in parentheses. The set notation, I'm just going to write it as x, putting it in context, starting with the 467, less than x, less than 523. And these are some examples of setting up inequalities, solving inequalities, interpreting the results, and writing the solutions in two different types of notation.